Alright, let's get going with lesson 3.5. This lesson is about writing and graphing equations of lines. This is a lot like the second half of 3.4, so if you understood that lesson well, you'll probably understand this lesson well. If you struggled with that one, alright, you might struggle with this one a little bit. It's going to feel a lot like algebra class again. Alright, so want to focus on two things. Slope-intercept form of a line first, point slope. We talked about both of these last time, so let's just focus in on one of these at a time and make sure we know what we're talking about. So, slope-intercept form of a line, y equals mx plus b. M stands for our slope. The b is the y-intercept. That's the spot where our line crosses the y-axis. Remember, the y-axis is vertical. Okay, y-axis goes up and down. Okay, x-axis is horizontal. All right. Our other one is point slope form. Y minus y sub 1, remember this is down below, it's not a power, equals m times x minus x sub 1. M is the slope still, x sub 1 is an x value, it's a number. Y sub 1 is a y value, it's also a number. Okay, you can use either one of these, point slope form or slope intercept form. I really don't care as long as you're showing your work. Alright, here we go. We're going to write the equation of the line that passes through the point negative 3, 2 and is parallel to the line y equals 2x plus 7. So go ahead and copy this down, pause it if you need to, alright, and then we're going to get started. Alright, I'm going to get started. Remember, if you need to copy it down, I didn't give you enough time, just pause it. Alright, so keep in mind our steps from back in lesson 4. First thing we need to do is we need to find the slope. Now, the key word here is parallel. Okay, remember what we learned back in lesson 4 about parallel lines? Parallel lines have to have equal slopes. So look at this equation here. What's the slope of this line? Okay, the slope of this line, y equals mx plus b, the slope is 2. And parallel lines have equal slopes. Right, so the slope of the line we're going to be working with is still m equals 2. Alright, then we have an x and a y value. X equals negative 3, y equals 2. That comes from right here. Okay, you guys remember what this plus 7 has to do with the problem? The original plus b has absolutely nothing to do with the problem. Nothing. Absolutely nothing to do with the problem. Alright? Now, if we're going to use slope-intercept form, y equals mx plus b. So our y value is 2, m is also 2. X is negative 3 and plus b. Remember, the plus 7 has nothing to do with the problem. Alright? 2 equals negative 6 plus b. We add 6 to both sides. This cancels. We get 8 equals b. We have to finish by writing the equation of our line. So we go back to y equals mx plus b, but we leave y as y. Y equals m, remember, was 2. X is just x. Since this is a positive 8, we put plus. If it was a negative 8, we'd put minus. So 2x plus 8. Alright, let's look at what it looks like with point slope form. So y minus y1 equals m times x minus x1. Okay, remember, in this case, y is just y. Over here, we didn't use a y sub 1. Alright, we actually put the number in for y. Over here, though, we put the number in for y sub 1. So that can get a little confusing. You got to make sure you know where these things go. I don't care which one you use. Pick one, get really good at it, and then just stick with it. Okay, over here, though, y minus our y value of 2 equals m. Remember, m up here was 2. X minus, remember this right here, negative 3. Okay, what do we do with a minus and negative? We treat that like a positive. Okay, so y minus 2, we distribute 2x plus 6. Add the 2 to both sides. This cancels and we get y equals 2x plus 8. Same exact answer as we got over here. Same answer. So you can get the same answer either way using either form. Alright, well, let's look at that. Let's graph that. Okay, this lesson, remember, was about writing and graphing equations of lines. So we're going to graph both of these lines. Okay, we're going to see if they actually are parallel. So we've got y equals 2x plus 7, and we have y equals 2x plus 8. Alright, so I've got a graph here, graph paper. Alright, now I'm going to kind of darken up a little bit of this just to say, okay, here's my x and y axis. All right, so let's darken this up a little bit. And that didn't seem to make it much darker. Thicken it up even a little bit more. All right, hopefully you can see that all right. Trying to make sure I'm going to be able to fit my my lines way up there at the top because it goes up through +7 and +8, so they're going to be kind of high up on the graph here. All right. Okay. So hopefully you can see where the lines are a little bit darker, but this I'm going to go ahead and put a kind of a dot right there. That's 0, 0. All right. So how do we graph y equals 2x plus 7, our starting one, right? Remember y equals 2x plus 7, that was one we wanted to be parallel to. We start with the y-intercept, right? So we're going to go up to the positive 7. 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to put a dot right there. And my slope is 2. It was a positive 2. Remember this idea of rise over run? So 2 is the same as 2 over 1. So that means I'm going to rise 2 as I run. Run is a horizontal distance, 1. Okay. It's positive. It's going up to the right. I can do that again. Up 2 and right 1. I don't really like the word over. I may say it every now and then, but I try not to, because over doesn't tell me whether I'm moving over to the left or over to the right. Okay, so up 2, right 1. Now we can also go down 2. That would be like a -2, and we can go left 1. That would be like a -1. A -2 over a -1. The negatives cancel out, and it still gives us a slope of 2. Okay, so we can do that if we want. All right, so let's draw this line. Okay, that's y equals 2x plus 7. Now let's do y equals 2x plus 8. So coming back to my 0, 0, 1, 2, 3, 4, 5, 6, 7, 8 is right there. I'm still going to do a slope of 2. So rise of 2 and a run of 1. Rise of 2 and a run of 1. Puts me right on the edge of my graph paper. Remember, I can go down 2 and left 1. Okay, and I'm going to draw this line. And you'll notice that these lines are parallel. Okay? Y equals 2x plus 7, y equals 2x plus 8. They have the same slope of 2. All right, let's take a look at another example. Write the equation of the line that passes through the point 4, -1 and is perpendicular to the line 2y plus 4x equals 7. Okay? Now copy that down. Remember, I'm not going to wait very long, so you need to pause it and get it all copied down, then we're going to move on. All right? Okay, here we go. Now, this makes it a little bit more difficult. I don't know the slope right here. Okay, so we got to work on this thing to find the slope. So 2y plus 4x equals 7. I'm going to subtract 4x. These cancel. So I get 2y equals. Now the order we like to put these in, these are not like terms, so I can't do 3x. Okay, it doesn't say 7x minus 4x, it just says 7 minus 4x. But we usually like to have the mx plus b, the mx part first. So I'm going to write -4x first, and then it's a positive 7, so I'm going to put plus 7. Okay, I still don't know the slope yet because I have this 2 here, and we want y equals something, so I have to divide by 2. I'm going to divide by 2 here and here. Okay, divide by 2 everywhere along the way. So y equals -2x plus 7 halves. Now this can get a little confusing, except remember, what does the plus b have to do with the problem? Absolutely nothing. Nothing. The original plus b has absolutely nothing to do with the problem. So what's my m here? My m is -2. But that's not the m we're going to use in the problem, because remember, this is perpendicular. Okay, we talked about perpendicular slopes, and perpendicular slopes, perpendicular lines have slopes that are opposite reciprocals. So what's the opposite reciprocal of this? So my new slope. Well, opposite of a negative makes it a positive. What's the reciprocal of 2? Well, 2 is 2 over 1. So the reciprocal of that is going to be 1/2. That's the slope we need to use as we go through this problem. All right. Once again, I'm going to show you how to do this two different ways. So we're going to go y equals mx plus b. All right, I have m equals 1/2, x equals, from up here, 4, and y equals -1. Squeeze that in right there. And that comes from right here. Okay? So, -1, that's my y, right here, equals m 1/2 times x plus, remember, b has absolutely nothing to do with the original b, so it's just b. Alright, what's 1/2 times 4? 1/2 times 4 is 2, so -1 equals 2 plus b. I need to subtract 2, that cancels, I subtract 2 here, I get -3 equals b. Now I need to write my answer. Don't use this slope. Okay, make sure you're using your new slope. This slope you used right here. Slope you used right here. Keep using that slope the rest of the way through the problem. So y equals mx. Remember I talked about not putting the x down here with the 2 so it looks like it's in the denominator. I'm going to put it right next to the fraction. Y equals 1/2 x mx plus b. Now plus -3. We don't want to write it that way. We want to keep it simple. So we just write -3. So there's my answer. Okay, let's do it point slope form. Y minus y1 equals m times x minus x sub 1. Y minus, right here, -1. Well, minus a negative is positive, so y plus 1 equals m is 1/2. X minus, remember the x value is 4. Okay, we're going to distribute 1/2 x minus, what's 1/2 times 4? It's 2. Subtract 1 here and here, these cancel. Y equals 1/2 x minus 3. Notice I get the same exact answer either way. Okay, next one. Write the equation of the line that passes through the point -2, -5 and is parallel to the line x equals 12. Looks like I gotta zoom out a little bit to fit all that in. That's too far. All right. Write the equation of the line that passes through the point -2, -5 and is parallel to the line x equals 12. Now remember, these ones, when they don't have this whole y equals mx plus b, they're supposed to be really, really easy questions. Okay, it's parallel, and it's x equals 12. Remember Hoy and Vux from the other lessons? So this is an x, so it has to do with this one. It's a vertical line. What kind of lines are parallel to vertical lines? Well, other vertical lines. So I need a vertical line for my answer. Vertical lines are always x equals a number. So we're going to write x equals, and we look up here, and what does x equal? It says x equals -2. Done. No work. Don't really have to show any work. I just got to write it down. I got to think through and write it down. Okay, let's look at this one. Write the equation of the line that passes through the point 4, 7 and is perpendicular to the line x equals -1. So copy that down. Once again, pause, rewind if you need to, but get it copied down because I'm going to move on pretty quick. Okay, same thing. We're going to use that Hoy-Vux idea. Alright, this, it's not in that whole y equals mx plus b, so it's this right here. It's x equals, so it's a vertical line. Vertical lines are perpendicular to horizontal lines. So my answer is going to be a horizontal line. Horizontal lines have to be y equals. So what does y equal? Well, look back up here. What does y equal? That's an x value, that's a y value, so y equals 7. And I'm done. Okay, pretty simple. Alright, one last example and we're done. This one's going to take a little while. First off, it's going to take a little while to copy it all down, so pause as necessary so this video doesn't get too long. So I don't have to wait for you to write it all down, so you just pause it. All right, write the equation of the line that passes through the point 6, -4 and is perpendicular, that's going to be important, perpendicular to the line that passes through the points 4, -1 and -2, -3. So let me zoom in on that part if you can see that. 4, -1 and -2, -3. Alright, got the point 6, -4. There's a lot of points going on here. Alright, so first thing we have to do, we have to find our slope. M equals. Alright, well I didn't give you the m. It's not in y equals mx plus b form. It's not even like this line back here on one of our earlier examples that we could change into y equals mx plus b form. Alright, so how in the world do I find this m with these 2 points? Remember our slope formula? Y sub 2 minus y sub 1 equals x, or over x sub 2 minus x sub 1. So what's y sub 2? It means the second y value. Remember, it's not a power, it's not squared. Second y value. So I come up here, there's my second y value. It's negative 3. Minus my first y value, which is negative 1. Over my second x value, which is right here, negative 2. Minus my first x value, which is 4. Okay, what do we do with a minus and negative? We add. Negative 3 plus 1 is negative 2. Negative 2 minus 4 is negative 6. A negative over a negative is a positive. And 2 divided by 6, we reduce that to 1/3. Alright, there we go. All that work to find m, the original m. But it's perpendicular. What do we know about perpendicular lines? Their slopes are opposite reciprocal. So this is not the slope I'm going to use. All right, I have to use a new m. I need to do opposites. So that's a positive, so my new m is going to be a negative. What's the reciprocal of 1/3? Well, I got to take that fraction and I got to flip it upside down. So it's going to be 3 over 1. I don't really need to write the over 1 part, so just negative 3. That's my new m. Alright, we already know it's got to go through this point. So now I'm going to use this x and y. I don't need to use these anymore. Use this x and y. So x equals 6 and y equals negative 4. Okay, once again, I'm going to show you 2 different ways to do it. So y equals mx plus b. Alright, remember, you don't have to do both methods. You can pick one, do the one you like the best, and then write your answer. But I'm going to always show both in the videos, so no matter which way you want to do it, you can check to see if your answer is right and if your work is right. So y equals negative 4, m, new m, is negative 3, x is 6, plus, well, what about the b? Remember, that's what we got to solve for. There was no b anywhere in all this previous work, but it doesn't matter because the original b has what to do with the problem? Absolutely nothing to do with the problem. Okay, so plus b. Negative 3 times 6 is negative 18. Negative 4, and my plus b. I have to add 18 to both sides. Negative 4 plus 18 is 14 equals b. Now I need to write my answer. Remember, use your new m, not your old m, when you write your answer. The same m you used right here. So y equals negative 3x plus 14. Okay, let's go do it with the other method. Y minus y1, y sub 1 equals m times x minus x sub 1. Alright, y is just y in this case, but y sub 1 is this negative 4. Minus a negative 4, m is negative 3, x minus 6. I'm going to change this over to a plus 4. We're going to distribute here, so negative 3x, negative times a negative there is a positive 18. I'm going to subtract 4. These cancel. I get y equals negative 3x plus 14. Same exact answer. Now, we're going to graph this one. And with that plus 14, I got to be careful. I'm going to make sure I move my kind of 0 point down the paper a little ways, but I'm going to go ahead and graph this. So first off, I'm going to graph these 2 points. And I'm going to draw the line through them. And then I'm going to graph this line, and I'm going to check to see if it actually goes through 6, negative 4, and does it look like it's perpendicular to the original line. Okay? So, knowing that I've got to work all the way up here to 14 somewhere, I'm going to come way down here, and I'm going to graph. I'm going to go ahead and use this kind of as my center. So let me darken these up a little bit again. I know it's kind of hard to see sometimes on the video, but hopefully you can see it a little bit. I'm going to darken that up for my x-axis. Here goes my y-axis. Alright, remember we're going to graph the 2 points that we were told in the original problem, which were 4, negative 1, and negative 2, negative 3. Okay, so 4, 1, 2, 3, 4, negative 1, and negative 2, negative 1, 2, negative 3. Okay, so those are my original 2 points. I'm going to connect them and draw that line. Draw it nice and long because I'm not really sure where this other one's going to intersect it. Okay. All right, now I have the point, it was 4, -1, right? No, that was the other one. 6, -4. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 6, -4. Better go through this point when I'm done, okay? All right, so here we go. What in the world does this look like? Remember, I had the equation y equals -3x plus 14. -3x plus 14. So I'm going to start here and I'm going to work my way all the way up to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right there. Put a dot. Slope is -3. Remember, negative slopes come down with that idea of rise over run. So down 3, right 1. If I go down 3 and left 1, it would be going up to the right. That's a positive slope. So I go down 3 and right 1 and put a dot. I'm going to go down 3 and right 1 again. I'm going to go ahead and do that one more time so I get a pretty good idea what my line looks like. Now I'm going to connect that line. Okay, a couple of things I'm looking for. First, does it look perpendicular right here? Yeah, that looks like a right angle. Okay. And look, it went through that point. That's important. Okay. If I kept going down 3, right 1, it'd be right there. Down 3, right 1 would be right about there. And then down 1, 2, 3, right 1 puts me exactly on that point. So I know it's good. All right. So now this also goes back to that perpendicular postulate. Okay. If you guys remember the perpendicular postulate, hey, if I've got a line and I have a point that's not on that line, how many lines would go through this point that are perpendicular to this line? The answer was exactly 1. And you know what? We found its equation. That's really what this lesson is all about. It's about the perpendicular postulate and the parallel postulate that say, hey, if I've got a line, all right, that's what all of our things were. Let's look at one of our first examples from today. Okay, I've got a line right here. And I have a point that's not on this line. How many lines go through this point that are parallel to this line? The answer is exactly 1. Okay, well, if there's only one answer, find its equation. Well, we did that. Okay, our second example. Okay, same idea. I have a line and a point that is not on this line. How many lines would go through this point that are perpendicular to this line? The answer is exactly 1, and it's this line. I have a line. In this case, it's a vertical line, but it's a line. And a point that's not on that line. How many lines go through this point that are parallel to that line? The answer is exactly 1, and this is that line. How many lines go through this point that are going to be perpendicular to that line? The answer is exactly 1, and it's that line right there, and so on. That's really what these lessons are about. So yes, it feels like algebra class, but it's going back to the parallel postulate and the perpendicular postulate that say, hey, when you got a line and you have a point that's not on that line, you're going to get exactly one answer, whether it's parallel or perpendicular. You need to be able to do the algebra to figure out that answer. So that's what lesson 3.4 and 3.5 are both about. All right, we'll see you guys in class.